This is the lab setup for the two-dimensional tension activity. The purpose of this activity is to give us more experience in how forces interact as vectors, in particular how forces in strings, which a force in a string we call a tension, how forces in a string also follow our rules for adding vectors. So our setup is here, we're going to have a weight hanging from a loop, so this will be straight up and down, and then I'll have two probes tied up to the poles at different angles, and there's only one loop in this example, but you're going to have three loops. So you have a left-hand loop, then you have another loop here and another loop here, and your instructions are going to tell you to put 500 gram mass on the left-hand loop, and then you take your data, then there'll be another loop here, you'll hang your 1,000 gram, and then you'll have to combine the two to get your 1,500 gram mass. So you're going to have three trials in this lab. Here's a close-up of where all three strings come together. You'll notice that the probe needs to be lined up, so you might want to watch that in case it gets, if my probe is running this way, my string's this way, then the force I read wouldn't be accurate. This is a little demonstration of how to measure the angle. Now, later in the video, when I show you what your notebook is supposed to look like, you'll see that there's a diagram in your lab notebook. Let me pause it here. There's a diagram in your lab notebook which shows you how the forces add up. So the angles we're talking about on the left hand and the right hand angle are the angles to horizontal. So what I really want is this angle right here and this angle right here to horizontal. So, but that's hard to measure. So the easy thing to measure is put the whole of your protractor where all three strings come together. Use the fact that the string hanging down gives you a nice reference line, and measure the big angle and just subtract 90 degrees. Now it's going to be tricky, but you should be able to get within a degree or two, because it's really hard to hold the protractor. You can see I'm kind of wiggling a little bit. So just do the best you can. So that measures the left angle. You would measure your right hand angle the same way, you just flip your protractor the other way around. So that's how we measure the left hand and the right hand angle in this lab. To read the forces, you just they're both plugged into the LabQuest, and we've done this before, so you just read force 2 and force 3. Depends on what gates you plugged it into. But anyway, you're going to have two forces. You just need to keep track of which one's which. One is the left and one is the right. And that's really all there is to collect the data. So the data collection in this lab is simpler than many of them. And then you can see in your lab notebook example how to calculate all the data that goes in the table and how to find the percentage differences. Good luck. This is what I expect your lab notebook to look like for the two-dimensional tension activity. You should have this vector diagram sketch. This is just a sketch, it's not drawn to scale, just to make sure help you understand what it is that we're measuring. This sketch right here will match the lab setup. Then you'll have the table, everything in black you could go ahead and put in before you even collect the data. We're going to do 3 trials as you've seen in the earlier video, and this is the data we're going to collect. And then, as always, for row 1 we'll do the calculations. You have to show those calculations. Notice I've marked that you're going to measure the two angles, the two tensions, and because on the scale you weigh the downward force, you'll measure that one too. After that, you'll calculate it. Again, these numbers are just totally made up by me. There's no way you guys are going to have 100 Newton forces on here, so don't think your numbers need to match, but this is the procedure you would take. And I put the formulas in here, and this is just like we've been working in our vector diagram worksheets. It applies to tension. The left hand force for X is FL cosine theta, and so on and so forth. And I think you can follow this. I have a percentage difference for my horizontal forces, and down here I have a percentage difference for my vertical forces. Again, you have a picture of this. In fact, you have a blow-up picture up close in your lab notebook in case you're having trouble seeing this in the video. You only have to do the vector diagram for trial 1. I'm being nice. I don't know what's wrong with me. So you draw it to scale, and then, and it really did turn out this way, my two forces turned out to be exactly what I had in the table. If you're careful, you should be pretty close. So, and I just would like you I put what my scale was, and then I just showed that 50 newtons is 5 centimeters, 52 newtons is 5.2, and if you're careful, everything comes out pretty close. Then I measured my left-hand angle, and I measured my right-hand angle, and I was a degree off in my angles, and I measured the length of my right-hand force and the length of my left-hand tension, and those actually came out exactly like I had in my table. So that's all you have to do for your lab notebook. Good luck.